So I know some of you were familiar with that. How do you know, where have you heard of the word pedigree? Caitlin?
I feel like it's like a dog food brand.
So it is a pet food brand, but it's called that because, does anyone know it in like a different context? You know? Okay.
I watched a dog show one time, and that's a dog, by the way.
Okay.
They call like the dog, they actually call the dog a pedigree.
Yeah, so it comes into play. It's often used with animals in terms of their ancestry. A dog's pedigree shows you who that dog's parents were and who their parents were, or like racehorses. It's used to trace back if you are getting, say, a purebred husky. Like, to sort of be sure that what you're getting is a pure husky, they might provide you with the dog's pedigree, which says, here's the dog, here's who its parents were, who their parents were. So it allows you to sort of go back through the generations and trace the ancestry of that animal. So pedigrees are also used in other situations. So pedigrees, we're going to use human examples typically. A pedigree is basically like a family tree almost. It shows the ancestors, the relatives of an individual. And we draw it like a family tree, and we have certain symbols that we use, right, consistently. So we use a square shape to indicate a male. A circle shape indicates a female. And often pedigrees are used to indicate if a person or a family has a certain trait or condition. And you might trace a disease through a family or a certain trait that they have. And if they have that trait, you typically will shade in their symbol. So here's a male that has whatever trait we're tracing. Here's a female that does. We connect individuals in the pedigree with lines to show the relationship. What do you think this line horizontally connecting those shapes means? Mitchell? No? You know?
Like marriage.
Yeah, sort of marriage or not. I mean, it could be that they had children as well. Because obviously marriage, having children doesn't have to include being married legally. So it means that these two individuals had children. So then what does this mean? So slightly different. Caitlin? Yeah, these are two siblings. This is a brother and sister. Who's going to be connected up top?
Parents.
Yeah, they're parents. Okay. And so those are how we represent siblings. And so now you know sort of the basics that you could draw a pedigree of a family. So let's look at an example. Okay, this time we're going to trace color blindness through a family. So we say a man that's colorblind, there's a woman that's not colorblind, we have 3 children, a boy and 2 girls. None are colorblind. Okay? So a man that's colorblind, what symbol are we going to use for that person? Square? A square. Are we going to shade it in or not?
Yes.
There are both answers.
Yes.
Yes, because that's the trait we're tracing. He is colorblind, so we're going to shade in his symbol. What about his wife? Where is her symbol going to go? Right next door, and they're going to be connected horizontally. Where are their children going to go? Below them. So we'll draw a line down between the two, and we'll draw like a little space for the 3 siblings. None of them are colorblind. So what are the symbols that we need?
Circle.
1 square, 2 circles. Are any of them shaded? No. Now we could make a pedigree that goes for several generations. This is just a 2-generation pedigree. You could go 3 or 4 or 10. Obviously, they get more and more complex as you go multiple generations, but the process is the same. So let's just make, yeah, Caitlin.
Well, my uncle was colorblind, but my aunt isn't, and they have 3 children, 2 girls and 2 boys.
Wow. It's almost like I made this based on that. That's interesting. So color blindness? Color blindness is kind of interesting. Do you know anything about color blindness?
Yes.
Seven? Correct. So it doesn't mean if a person is colorblind, typically doesn't mean like they see the world in black and white. What does it actually mean then? Yeah. Yeah, is that certain colors look the same to them. That to a person with normal vision can differentiate between those colors. Okay. Do you know color blindness affects certain individuals more than others? How many people know someone that's colorblind? Okay. Put your hand down if they're a woman. So they're all
They're more rare to get colorblind.
Correct. So males are more commonly affected by color blindness. And there's a reason for that. Color blindness is what's called a sex-linked trait. Sex-linked traits, the gene for them is on the X chromosome. And it's recessive. So for a man to become colorblind, how many recessive genes does he have to get? Just one. He only has one X chromosome, right? So if he gets one recessive gene, he'll be colorblind. If he gets a normal gene, he'll have normal vision. How about a woman? She has 2 X chromosomes. So if she gets one recessive gene, is she colorblind? No, because she has a normal dominant gene to cover it up. So it takes 2 colorblind genes for a woman to be colorblind. For those sex-linked traits, typically they're more common in men, because men only have 1 X chromosome. So have you seen these sort of pictures? They probably gave it to the eye doctor. And what's the point of these? How do they tell if you're colorblind? Why is this, Jake? Yeah, so if you're not colorblind, you can see the difference between these oranges and blues. You see a number there. A number? Yeah, if you have the type of color blindness in which you can't tell the difference between blue and orange, you just see a bunch of circles. There's different types of color blindness. Okay? So the most common one is red-green color blindness. Okay? And in red-green color blindness, what happens is the red, so you see the colored pencils, the red, this is normal vision, but in a person that has this type of color blindness, the greens and the reds and pinks, they kind of all look the same sort of brownish color. Same thing, this would be sort of a flag if a person had that type of color blindness. And he was putting them. Yeah, because you can't tell. I know people that are like sometimes soccer coaches or referees, like depending on what uniforms the teams are wearing, they have a hard time. Like obviously, if you have a hard time telling red from green, and you're a referee, and one team's wearing red uniforms, the other team's wearing green uniforms, then they kind of look the same, so it's hard to distinguish. There's other types of color blindness as well. We don't have to stick to all of them. So these are just a bunch. I'm asking.
15, 26, 20. I got 11. I can't see the last. I don't see anything in the last. Okay.
That's the control. Why would a doctor show you this?
To trick you.
To see it, not to trick you, but to see if you're like making it up and saying, "Oh yeah, I see a 3," and then there's actually not.
I thought I saw it. I thought I saw 23.
All right, I'm gonna. These are so you guys got pedigrees.
Yes.
All right, I'm gonna skip these simple ones because they're too easy. You can do it on your own. I'm going to the more complex ones. These 2 generation ones are too simple. You need a challenge. And so look how bad we're accelerating. See? All right. So here is one that is going to be a bit of a challenge, as is your homework. So what I want you to do is read through this paragraph, and it's going to tell you about Joe and his family, and you're going to draw the pedigree of him. Now, let me give you a hint. Do not put Joe right underneath the paragraph, because later on in the paragraph, it's going to tell you about his parents and grandparents. So if you put Joe way at the top, you're not going to have any room to put his parents and grandparents. So this is tracing hitchhiker's thumb. That's the trait you're going to be shading. So go ahead, read this, and then in 5 minutes or so, I'll show you the answer, be sure we understand it, and then we can move on. So go ahead and draw this point. What? No, I want you to do it on your own. All right, here you go, the correct answer. We have Joe. Okay, his parents are going to go up here. How are we so far? Yeah, you could. The order can be switched. That's okay, as long as they're connected properly. No, because you don't know anything about them, so you can't. You don't know if they're shaded or unshaded. Good. That's everybody, isn't it? This is a 4-generation pedigree. All right. Yep.